let's say we're looking at a math exam with an approximately normal distribution, a mean of 72, and a standard deviation of 6. We want to know what percent of scores are above 84. So the first thing we can do is find our z-score. So remember, this is our observation minus the mean divided by our standard deviation, sigma. So in this case, we're interested in scores of 84 or higher. Our mean is 72, and our standard deviation is 6. So if we plug in all those pieces, we get a z-score of 2. Now, if we're exactly 1, 2, or 3 standard deviations away from the mean, which is what this means, we're 2 standard deviations above the mean. That allows us to use the empirical rule, so 68, 95, 99, 7 rule. This is just a rule of thumb. Those values aren't exact, but they're pretty good. So if we want to find from 2 standard deviations and higher, we're looking for the shaded area there. Since we're 2 standard deviations away, we're going to use this 95%. So that means that 95% of the data is within 2 standard deviations of the mean. So this middle portion is 95%. Now, because of the symmetry, that means that the remaining stuff is split between these 2 tails. So that means we have 95% in the middle, so 5% total for each of the 2 tails. So each of those tails is going to get half of that. It's going to get 2.5%. 2.5%. That means the probability of having a score, we call it x, that's at least 84, and it doesn't really matter if we say greater than or equal to or just greater than. So in this case, I'll say sure. I guess if we're being technical, above 84 would be strictly greater than 84. Then we would get that shaded region, 2.5%. Now, if you use a calculator or if you use a z-table, you're going to get a slightly different value. Again, this is just an approximation, but they should be fairly close.